So exponential functions are all functions in the real world. We talked about the fact that it models growth and decay. Do you understand that? Now, it's all in the form of a to the x. Now, right here I have y equals 2 to the x. Y equals 2 to the x is an example of an exponential function. If I have 10,000 to the 0 power, what is that outcome always in forever? 1. So what I'm telling you is anything raised to 0 power is always in forever 1. This is important for you to understand when dealing with exponential functions. Now, we are going to graph the function y is equal to 2 to the x. Now, how do I graph y is equal to 2 to the x? I need to make an xy table. So if I make an xy table, I'm going to first do -2, -1, 0, 1, 2. So those are the values that I'm choosing. Why am I choosing positive and negative values? I need to see both sides of the number line, right? Positive and negative values. First thing I'm going to do is I'm going to plug in 0. What's 2 raised to the 0 power? 1. Our brain understands that. Fine. What's 2 to the first power? 2. What's 2 squared? 4. Now, the next thing, negative exponents. This is where things fall apart for you guys. If I have 2 to the -1, what's actually happening to this? Turn around and look at the red poster in the back, please. Alex? It will be a fraction. You're absolutely right. If it is negative, if you have a negative exponent in the numerator, to make it a positive exponent, you're going to move it down to the denominator. So that gives you the 1/2. So if I have 2 to the -2, that's going to be 1 over 2 squared. And what's that going to give you? 1/4. So what I got going on here is going to be -2, 1/4, -1/2, 0, 1, 1, 2, 2, 4.
Where's the negative numbers come from?
Pretend that didn't have a little bit of a curve. I'm choosing values that are positive and negative on my x number line.
Oh, never mind. All right, I was looking at it wrong.
Now, what I want you guys to observe here is what do you notice about this graph of y equals 2 to the x? It gets really close to what value?
0.
It gets really close to the x-axis, doesn't it? Does it ever touch the x-axis? No. Which, if it doesn't touch the x-axis, what is that?
Okay.
Horizontal. The horizontal asymptote. Where?
0.
So what you need to understand is that this is an increasing function, right? It's an increasing function, and it has an asymptote of y is equal to 0 because it's a horizontal asymptote, right? And what's my y-intercept? Again? 0, 1. What's my x-intercept? What's the definition of a y-intercept? The point on the graph where it crosses the y-axis. Is it crossing the y-axis at 0, 1? Sure is, so that's why I have the point 0, 1. What's my x-intercept? Why am I not going to have any x-intercept? Because I have an asymptote at y equals 0, correct? So therefore, it's never going to cross the x-axis. These are all pieces of information that you need to understand about an exponential function, okay? Do we get that, yes or no?
So if it's declining, will it go from that down?
Let's talk about that in a moment. Okay.
So wait, hold on. Quick, how do you get the asymptote y equals 0?
Because it's getting really, really close. Let's say I have 2 to the -5. That's 1 over 2 to the 5th, which is 1 over 32, right? Is that really close to 0? How about 2 to the -50? Is that going to be even closer to 0? So this thing is going to get so ridiculously close to 0 that it's going to look like it's laying directly on the x-axis. But is it ever going to touch the x-axis? No, which is why we have a horizontal asymptote there.
So is it always y equals 0?
It is always y equals 0 unless we have shifted the parent function. And I'm going to talk about that next. Okay? Now, there are some rules of exponents that we need to first review to make sure that you guys understand these. We talked about these at the beginning of the year. These are not new. They are ones that we did at the beginning of the year, so there's something that you should already know. If I have a to the x times a to the y, that means I have the same exact base for two different exponents. Look at that. You are awesome. Who made that?
Someone bought it.
Either way, it rocks. Tell me the thanks. Thank you, ma'am. You're welcome. A to the x times a to the y means I have exactly the same base, so I can add my exponents to give me x plus y.
Is that really dumb?
Okay, now, if I have them attached by division being the same base, and I have different exponents, since they're attached by division, I can subtract the exponents. A to the x to the y means that I'm going to attach them together by multiplication, so I can multiply x and y together to get a larger exponent.
Yeah, I didn't.
They're attached by division, so you subtract them.
Oh.
Number 3 is they're attached. They have one base with two exponents, so you multiply the exponents. Number 4, this is understandable. Anything raised to 0 power is always and forever.
1.
1.
And how am I going to this? Well, I'm here, maybe. Not a board, right?
Why did you erase that? You're not supposed to be there.
Well, because I want to show it.
Oh.
Okay. Now, if I have a to the negative x, that's the same thing as saying 1 over a to the x. If it was negative in the top to make it positive, you move it to the bottom, right? Now, if it's in the bottom and it's negative, to make it positive, where do you move it? To the top. Do we see that? Yes or no? Okay. Now, if I have a over b raised to the x power, both of those bases, a and b, get that exponent. You understand that? A to the x over b to the x. Same thing with number 7. If I have a and b in the parentheses, both of those get that exponent.
Well, one of these,
That wasn't me. I can't even whistle.
It was actually dead.
I didn't do it. I didn't know what you were talking about.
Now, number 8. Number 8 is one that kind of throws you guys every once in a while, so let's talk about this.
Birdies.
Now, if I have the absolute value of a squared, what happens to the absolute value of any number?
It's positive.
It's positive. What if I take any number and square it? What's the outcome?
Positive.
Positive. So what you're telling me is that the absolute value of a squared has to still be just a squared, right? It doesn't matter if I do the absolute value first and square it, or if I take and square it and then take the absolute value. It doesn't matter, because either way, the outcome is going to be a squared. Do we get that, yes or no? Okay. Now, transformations. A transformation, by definition, is up, down, left, right. That's what a transformation is, up, down, left, right. Now, we have several different parent functions. We have several different parent functions. The parent function I'm using up here is x squared. Do we all see that? So if I have x squared plus c, what happens to that function?
Goes to the left.
X squared plus c. It's going to go up c units. What if I have x squared minus c? It's going to go down c units. What if I have y is equal to x plus c quantity squared? It's the opposite of what you would think. It's positive, so that means you're going to go to the left c units. And then the last one there, x minus c squared. This is going to be right c units. Now, here's what you need to understand. This is your vertical, meaning it's tacked on at the end. this is inside the function, and this is that horizontal shift. Okay? The important thing that you need to understand here is that these are going to be transformations, up, down, left, right shifts. Okay? That same thing has to apply to our exponential function. So here is my exponential function, a to the x. Y equals a to the x is our new exponential parent function. What can a not be?
0, 1.
0, 1. That has to be greater than 0, right? Now, if I have a to the x plus c, what's happening to this thing? Up c. How about a to the x minus c? Down c units. Do we understand that? That makes sense, right? Because it's just another parent function. Now, what's the next one? A to the x minus c. It's going to go to the right c units. Are we changing the look of the function? No, we're just moving it over to the right 2 units every time.
Is it just going to A because of the
Why is that?
subtraction?
Because it's inside with the exponent. This is outside and taking the function and adding c units to it. Start going. Moving it up, moving it down. Okay? This means I'm actually taking and moving it to the left or to the right, which means I'm changing the x value.
Why can't you just have a minus x?
Are you good?
A minus c to the x. Or a plus c.
Because the x in this function up here, x was your coefficient, was your variable, I mean. And it's in the place of where a coefficient would be attached to it. This, a, is your base. X is your exponent. So if you're making this a horizontal shift, your exponent has to be the thing that changes, not your base. Does that make sense? Okay? So in this case, if I have a to the x minus c, that c, for it to be a horizontal shift, has to change the x, which is in the exponent position. The a does not change. Okay? This one right here is a to the x plus c. That's going to go to the left c units. Now, let's talk about these two down here. If I have negative a to the x, what is that actually? Isn't that negative 1 times a to the x?
Yeah.
If I had y is equal to x squared, that's going to look like this function right here, correct? If I had y is equal to negative x squared, what does that look like? It's flipped over the x-axis. So what do you think is going to happen to y is equal to negative times a to the x? It's going to be reflected over what? Over the x. It hasn't changed. It's still going to be reflected over the x-axis. So if this is reflected over the x-axis, what does y to the negative x have to happen to it? It has to reflect over the y-axis.
Be a lot of stuff.
Now, we have a base being E called a natural base. Do you guys remember me talking about E last year now? Let's do a little bit. I said it's a number like pi, where pi is 3.14. E is also going to be one of those irrational numbers. An irrational number that it's going to represent is going to be 2.718.
What is that? I don't understand where they came up with random.
Where they came up with pi and E.
Yeah.
Why they named them that?
I'm on the letter called the airport.
Why they named them that, I don't know. Where they came up. 22 over 7 is the closest thing to pi. It's the closest irrational number or rational number that you're ever going to get. I'm sorry? You can? You can say pi up to 100 numbers? No, you cannot.
I'll write it down.
Okay, you just like it? Like it's just a number that's really cool to you?
My freshman year, my teacher said I'd get 100 cards. I did it.
And it's too.
Okay, I need something like that.
That's impressive. But those are things like for me that I can look them up in a book and it's just not worth my brain remembering. But that is really cool. I really can't. I mean, that's really cool.
Does that make them smarter than you?
Makes them extremely intelligent. We all have our things that we're more intelligent than somebody else has.
Yeah.
You're more
Mine is
intelligent than you
not.
are.
It's like we should all be six.
We really should.
Shoes.
Okay, now tonight's homework is 131, 1 through 28 all. Now, this is not difficult homework, okay? It's not a difficult homework assignment at all. Please get your books open to section 3.1.
Are you gonna tell us the page?
Section 3.1.
It's not a page number.
Section 3.1.
Don't worry, I found it. I'm not even. Cool.
Page 185.
Told you that, huh?
See, do you look? I moved my stick.
I'm about to.
It was a little.
Page 185, problems 1 through 6. Say use a calculator to evaluate the function at the indicated value of x. Round the results for decimal places. So what are you actually doing there?
Take 3.1 to the power of 6.
You're taking 3.4 to the power of 6.8. That is a very simple concept here. Literally, it is plug and chug. 3.4 to the 6.8.
So all you're going to do is get a graph page and just type in that. Yeah.
So you're literally going to get a graph page. Get a calculator. 3.4 caret to 6.8. Enter. That's it. 4,112.03. Done. Do we understand how to do 1 through 6? Yay or nay?
Yeah.
We good? Okay. Number 7. Number 7 says graph the exponential function by hand. Identify any asymptotes and intercepts. Determine whether the graph of the function is increasing or decreasing. So you have 4 things you have to do. You got to graph it. You have to find the asymptote. You have to find the intercepts. And you got to tell me if it's increasing or decreasing. Yes? Okay, so if I graph this thing, -2, -1, 0, 1, 2, why am I using those values? The left and the right hand side, correct? If I start plugging and chugging, 5 and 0 gives me 1. What significant number is 0, 0, 1? 0, 1 would be considered a
X-intercept. Y-intercept.
and y-intercept. So I'm going to have a y-intercept being 0, 1. Yes? Okay, now, if I keep going, I'm going to have 5 to the first to give me 5. 5 squared to give me 25. 5 to the -1 gives me 1 over 5, right? Remember that? If it was negative in the numerator, make it positive, you make it go down. 5 to the -2 gives me 1 over 5 squared, which gives me 1 over 25. What do you notice happening as x gets really small? -2, -3, -4, -10, -30. Y gets really, really small, and it goes to what number? As x gets really small, a fraction gets smaller and smaller and smaller and smaller, and it gets so close to what number? 0. So do I have an asymptote? What's my asymptote? Y equals 0. Since I have an asymptote at y equals 0, do I have any x-intercepts? No, I do not have any x-intercepts. So if I graph this thing, I have something looking like this, don't I?
You don't have to draw the graph.
I want you to draw accurately, yes.
That's increasing.
Is it increasing or decreasing? It's increasing. As x gets large, the function is increasing, not decreasing. So did I do all the steps that it asked me to do?
Yep.
Did I graph it? Did I find the asymptote, intercepts, and told myself it was increasing and decreasing? Do we understand that? Now, I want to talk about number 13. Number 13. What's happening if I were to have 5 to the x minus 3? What would be happening to that graph? I understand. But if I had 5 to the x minus 3, what would be happening?
Going down 3.
It'd be going down 3 units, correct? So what you have going on here, I want to make this very clear.
3.
Here's 5 to the x. I had -2, -1, 0, 1, 2. And that was 1 over 25, 1 over 5, 1, 5, and 25, correct? What's 5x minus 3? 5 to the x minus 3 going to happen? What's changing, x or y? Y is changing. What's happening to that y value? It's going to go down 3 units from every one of those. So 1 minus 3 gives me -2. 5 minus 3 gives me 2. 25 minus 3 gives me 22. Now you have new points to graph, right?
So that's 5.
That's 5 to the x minus 3, right? Now what's happening to this 5 to the negative x? Well, if I have 5 to the negative x, it's reflected over what? It would be reflected over the y-axis, right? Which means, instead of, if I'm at -2, what's this going to be? If I'm reflected, just to make sure everybody sees this, I'm going to show you graphically. If I have 5 caret to the x, here's my function. If I hit tab and do 5 to the negative x, there's my function. They'll be symmetrical, right? Okay? So at 1, I would have, at 0, I'd still have 1. What would I have at -1? 5. What would I have at -2? 25. Right? What would I have at +1? +1 would be 1/5. What would be +2? 1/25. Do we see that they'd be reflected? Okay? So, this now becomes the 25. This now becomes the 5. This becomes the 1. This becomes the 1/5. This becomes the 1/25. So if I'm going to have -x minus 3, what am I going to do with all those values now? Drop them down 3 units. Do we understand that? Drop them down 3 units. So this would be 5 to -x minus 3, so this is going to give you the 22, the 2, and the -2. And these ones are just going to be ridiculous. You know, so tell me this, what would my asymptote be at? Can't be, because I shifted it, right? If I hit tab and go back up here, and I put -3, what's it going to get really close to? Get really close to -3. Is it ever going to touch it? No, so my asymptote is my vertical shift. Do we understand that? My asymptote becomes my vertical shift. Okay? Do we understand that, yes or no?
Yeah.
So now, sorry.
I know what you're saying.
My asymptote now is going to be at y equals 3. What's my y-intercept? 0, 2, right? Because I shifted it. I shifted it down. Okay? So if I'm looking at this thing, my graph is going to go like this. Okay? You can see it's going to go like that. So it's going to be a decreasing function. My intercept is going to be now at 0, 2. And my asymptote is going to be at y equals -3. Do we understand that? Do I have an x-intercept? Well, if I have an x-intercept, it is crossing the x-axis, so the only way you're going to be able to find that is by setting it equal to 0, and you can't solve that yet because you don't know natural logs yet, or logarithms. So you have to do it on graphic calculator. I'm more concerned about the y-intercept. 2. Okay, so just do your y-intercept.
That's supposed to be your comment. Because you went,
What's 2?
shouldn't it be negative?
Yeah, it should be negative, shouldn't it? The y-intercept?
Down 3.
Yes. Didn't mean to. I missed my sign. Good job. Okay, are we all understanding why it's 0, negative 2? I missed my negative there. Okay. All right, tonight's for homework is 1 through 28 all. Have a great weekend, folks. Make sure you do your homework.
We'll stay a little bit after that.
So what's your code?
Just go. Can I stay a little while after that?